Hello guys, welcome back to Math Zone African Motives. We are still on our mathematics for grade 10, and this is a condition that is very, very important in our syllabus, working with functions. We have got the condition of a parabola. A parabola is one of the functions that we need to understand, and I'm not going to talk much about this, but I'm just going to give you a basics of what you just need to understand. The whole part of your syllabus, you're done. Okay. We were supposed to actually have a normal parabola, which is found in a way that we have it in this manner, where it can be of, all right, let us take y is equal to a function of f of x, or we're going to have our parabola in this way. In the sense of this, knowing that we have y is equal to ax squared plus bx plus c, which is the format of a quadratic expression. So we have this, the highest exponent as 2 to give us a parabola. So in our syllabus, we are going to notice that the bx is not going to be there. We shall have a condition of ax squared like this, plus a c, or it is just going to be ax squared like this. These are the two things that you're just going to need in your to know in your syllabus. The first one of y is equal to ax squared, whereby this a is not equal to 0. So a can be greater than 0. If this a is greater than 0, that means we're talking about positive values. Our a is positive. We shall have a condition of our function in this manner. This being our x-axis, this being our y-axis. So you shall have your curve or your graph symmetrical about the y-axis. So it shall be like this. Symmetrical about the y-axis, meaning to say the y-axis, it divides our graph into two equal parts. This side of the graph is equal to this side of the graph. It is being divided into two equal parts. So this will be our function. If a is greater than, it's the shape also, it's like this, okay? The shape, it's a smiley shape that you're going to have there. And also passing or turning at 0. Because of this, we have got ax squared. There's nothing that is being added or being subtracted at that condition. On a condition that this a is less than 0, we're talking about negative values. On this condition, we shall see that our graph is going to be given as, or we shall have our graph as this way. We shall have our graph this way in the negative side. Also symmetrical about the y-axis, all right? It is going to be symmetrical about the y-axis. The y-axis is the axis of symmetry, whereby it divides our graph into two equal parts. This region and this region are two equal parts. And also, if we consider the turning points of these graphs are at 0, 0. This is our turning point. This is our turning point. So this is a condition where a is less than 0, where a is a negative. So considering this, there are so many things that you can have. A, yes, it's a positive, but we shall see a condition, maybe this a is a fraction, it's a positive, maybe we've got y is equal to 3x squared, and we've got y is equal to half x squared, compared to the graph of, let's say, y is equal to x squared, which is being a positive. The effect that you're going to see is that if this is, let's say this is the graph of y is equal to x squared, it's a positive, this one, it's greater than 0. For the graph of y is equal to half x squared, this one, it's a stretch that is happening on the graph. So the stretch of a fraction brings a bigger part, or we're going to have it like this. This is what you're going to have, something like this. Still passing at 0. This is a stretch of y is equal to half x squared, compared to a stretch of y is equal to 3x squared. A whole number is going to be stretched inside. So you're going to have it something like this. This is the graph of y is equal to 3x squared, a sketch, compared to the graph of y is equal to half x squared, and the graph of y is equal to x squared, and the graph of y is equal to 3x squared. It is same applies even if it is a negative. So the fraction, it is more wider. If it is a fraction, it is more wider like this. For a whole number, it is a little bit inside like this, all right? Still at 0, but a little bit like it's inside for a whole number. For a fraction, it is going to be wider. It is going to be wide open, okay? That is how we can differentiate this part. So like I said, this is the effect of this A. What about the other effect? The other effect that you're going to have is a condition where we have got y is equal to ax squared plus b. All right, let us just say plus c, because the bx is not there, plus bx plus c, whereby a constant is being added. So c, it's a constant that is being added. So it can be plus or minus. This is a constant that is being added. So the c, it simply represents a vertical shift. This one, it represents a vertical, this is a transformation, a vertical shift. All right, so for a plus c, you're going to have, you shift c units upwards. So you're going to shift c units upwards, c units upwards. All right, it's a vertical shift. For a negative, if this c is a negative, all right, for a negative c, you are going to shift c units downwards. So you're going to move the units downwards. It's a shift. It's either going up or it's going down. So these are the effects that can happen on any graph. Maybe it's the graph of y is equal to minus x squared. It can be added 3. It can be subtracted 3. All right, that's the effect of, it's a transformation. So I'm going to explain with these graphs, how do you transform these graphs from the normal graph that we are used to, which is the normal graph is this one. The one that we are used to, the one that I was explaining, when it is just in the form of y is equal to ax squared, where it is symmetrical about y-axis and everything passes through the origin at 0, 0, that is the turning point, and also the solution. But at this condition, you shall see some changes happening because the graph is going to be shifted upwards. You're going to shift that graph upwards, or you shift the graph down. So it's either it's going to end like this when being shifted, or it is going to end like this being shifted, depending, or it's going to end like this when being shifted. It depends. Or it can be a combination of that part of the stretch that I explained, the stretch and the shift at the same time, the vertical shift at the same time. So I'm going to explain this with the questions that we are given here so that we can properly understand how do they ask these questions and how are you supposed to attempt these typical questions for any type of a question that you be given. So all the first questions we are given here, so these questions are to sketch. So like I said, guys, it's going to be important if you understand the basics that I've explained here. All right, let's take the first question that we're given. That is, we've got y is equal to x squared. So this is our d. Y is equal to x squared. Then there's a -4 there, okay? And the other graph is of y is equal to x squared plus 3. But here they're saying sketch the graph of y is equal to x squared -4 and x squared. So this is a mistake. It's supposed to be x squared plus 3, right? So this is just a mistake here. It's a 3 here. So this is x squared plus 3, all right? On the same axis, on the same set of axes. So this is just a sketch, right? We're just having a sketch. But the sketch is supposed to be meaningful. It's supposed to represent exactly what the graphs are supposed to give us. All right, that is the first question. Then the second one is to determine algebraically the coordinates of the intercepts with the axis, the coordinates with the axis. All right, we're going to talk about that. Okay, this is what you're having here. These are the two graphs. Remember what I said, we have got this part, the effect of the graph before is on this, y is equal to x squared. This is the original graph that we're supposed to have, y is equal to x squared, which is supposed to be like this. All right, remember our sketch, I talked about this. That is our x-axis. our y-axis, then that's a 0 here. And I said if this number here is greater than 0, whereby it's a positive, a is greater than, we're going to have a smiley shape like this, passing at 0. So the graph was supposed to be like this, at 0, symmetrical to the y-axis, then it goes up. Symmetrical to the y-axis, divided by the y-axis into 2 equal parts. This side is the same as what we see on this, that is to be symmetrical. All right, but because of the effect of the -4 that we see here, it means this graph was shifted. So instead of it to be at 0, it is going to be dragged down 4 units down, 1, 2, 3, 4. So instead of it to be at 0, we are going to see our graph now at -4. Instead of our graph to be at this point, it is going to be at -4. That is where we're going to have our graph. And also, because of this effect that we see, it is going also to affect, because it is going to be like this. It is going to be like this. It is now at, so meaning to say also these points are now available. We now have the intercept with the x-axis. That is how the graph is supposed to be like. All right. So since we can see that the graph is supposed to be like this, it's supposed to be like this from this effect. Symmetrical to the y-axis. But we need to know what is the point on the x and what is the point on the y. So the point on the x in the x-axis, always in the x-axis, y is equal to 0. So if y is equal to 0, we can just take it on this equation. 0 is equal to x squared minus 4. Take the 4, the -4 this side, it becomes a positive 4, which is equal to x squared. Introduce the square root both sides. To remove the square, we're going to introduce the square root. So that's the square root of 4, which is plus or minus 2, is equal to, remember the purpose of introducing the square root was to remove the square. So we've got x. So the x is going to be at +2 or at -2, meaning to say the graph is going to pass at x being at -2 and other x, the other side being at what? At +2. That is the intercept, the x values, x intercepts. So like I said, the graph has shifted down. It has a smiley shape like this, but it has shifted down like this. This is our graph, symmetrical to the y-axis. I want us to have a clear picture of this, like this. So at this point, this is the turning point, then it goes back up. So it is symmetrical to the y-axis. Symmetrical meaning to say it is divided into 2 equal parts by the y-axis at the point here, which is x being a -2, and the x value here being a +2. And the y value is the one that is indicated. This represents the y value, -4. The constant is the y-intercept, the y value, where the graph is now at -4. So the graph is now passing at -4. So the -4 is the y-intercept, and also it represents the turning point. It is referred as the turning point, the turning point. So it is the y-intercept, yes, but also it is the turning point. That's our y-intercept and also the turning point. This is our x-intercept, right? So that is how we could have drawn the graph of y is equal to x squared minus 4. Okay, so for the question, it was asking us to not just to draw, not just to sketch, but also for these graphs, we are supposed to determine algebraically the coordinates of the intercepts with the axis. That is the coordinates of the intercept. These are the ones now that we are determining the x and the y. So here it's +2, -2, and for the y-intercept at -4. All right. Then we move on to the graph of y is equal to x squared plus 3. So it is the same shape, which is going to be a smiley shape. It's a positive, so it's going to be the same shape. But this graph is being shifted 3 units up. It was supposed to be like this. This is the graph of y is equal to x squared. It was supposed to be like this. But it is being shifted 3 units up. The y value is now at +3. So it is now like this at this point. And there's no way it's going to pass through the x-axis, because the shape is like this. It's a smiley shape. It's like this. This is the shape. It's not like this. It's like this when it is a positive. So meaning to say the graph is going to be somewhere there, passing through +3, symmetrical around the y-axis goes up like that. So this is what you're going to have. Y is equal to x squared plus 3. The graph is just shifted. It was supposed to be like this on the normal condition at 0. But it is gone up, the plus, it's a shift, this one, 3. It has shifted 3 units up, 1, 2, 3. So at that point, here it is a 3. It has shifted a 3. So meaning to say the only point that we can see is the y-intercept, the y value, which is at 0, 3. It does not pass through the x-axis like this. This one, it had the x values, but this one, we do not have the x values. So that's it. That's the idea of these two graphs that we are given. All right, let's check the other part, which is the E. We've got other two graphs here, which is the graph of y is equal to minus 4x squared plus 4, and the graph of y is equal to minus x squared minus 2. Okay, so we have a negative this time, and the question again, the coordinates of intercepts are still needed. Okay, so if we are to consider what we have this time on our sketch, we are going to see that the normal graph was supposed to be the graph of y is equal to minus x squared. Like I said, this one is going to be like this. It's going to be a Z one. So we're going to have a Z shape like this. This was supposed to be the normal graph. Okay. But now because of the -4 that we see here, remember what I said, the negative, the number that affects here, the A, if it is a certain number and it's a whole number, it means the graph is supposed to be closer to the graph. The graph of y is equal to minus x squared is like this, minus x squared. So the graph of y is equal to minus 4x squared is supposed to be closer, like inside, compared to a fraction or something else. Okay, so that is the condition. So meaning to say, before we talk about the shift, we need to know that it's just like a little bit like this, instead of to have something like this. Okay, it's gonna be a little bit closer to the y-axis. Okay, we've got a whole number on that part. Okay, but there is a shift there of 4 units, meaning to say the graph is, instead of it to be at 0 like this, it is going to be taken up 4 units up. So we are going to see this graph 4 units on top. We're going to see this graph on top like this, passing through 0.4, then it goes up or it goes down. Symmetrical to the y-axis, symmetrical about the y-axis. So this point is the y value, which is at 4. It is being shifted. A plus means it is going up. So it is now at +4. But we need to know the x values of this graph. That is where we're asked to determine this algebraically. So the x values, like I said, are at a condition where y is equal to 0 in the x-axis. So if y is equal to 0, you can solve the equation, because y is equal to 0, you're going to have minus 4x squared plus 4. So I can just transpose this so that it can be a positive. 4x squared is equal to a 4. So to determine x squared, I can just divide by 4 both sides. So this will be x squared is equal to 4 into 4, that's a 1. So to determine x, not x squared, we need x. We're going to introduce the square root both sides. So x is going to be plus or minus 1, the square root of 1, which is plus or minus 1. So this is a -1 on this side. This is a +1 on this side. All right. So these are the x-intercepts, -1, 0, and 1, 0. Okay, so that's it for the graph of y is equal to minus 4x squared plus 4. Okay. With the same information, we want to do it to draw the graph of y is equal to minus x squared minus 2. So like I said, the normal graph is of y is equal to minus x squared. It was supposed to be like this. This is the normal graph of y is equal to minus x squared. But the moment we have it a -2, it means the graph has shifted downwards. A negative, it is going down. So the graph is going to be shifted down, maybe at this point. But remember, this was a -4, and I said compared to the graph of y is equal to minus x squared. So the graph is going to be shifted down. So the graph is going to be shifted down, maybe at this point. But remember, this was a -4, and I said compared to the graph of y is equal to minus x squared. So the graph is going to be shifted down, maybe at this point. y is equal to minus x squared. The graph of y is equal to minus 4x squared is going to be a little bit inside compared to this. This one is going to be outer. It's going to be a little bit outer like this. Okay, this will be inside, but it has been shifted now, -2 units. So by being shifted, it's no longer at this point at 0. It is now at -2, but a little bit wide open compared, we are comparing in this case, minus 4x squared minus x squared. Minus 4x squared, it's inside. Minus x squared is outer. Okay, the bigger the value, the smaller the curve, the closer the curve it is. All right, the lesser the value that is becoming a fraction, and so on and so on. That is, the wider open the function is, the wider that function is. So that's what I'm trying to explain in this case. All right, so meaning to say, since we've got a -1 compared to -4, so -4 is the number, the 4 compared to the -1. The -4 is going to be inside. -1 is less. So the lesser the number, the wide open the graph is. So our graph is going to be like this, wide open. So it's going to be wide open like this. Remember, it's supposed to pass at what? At -2, a little bit wide open than this one. Okay, so this one does not have the x-intercept. It just passes through the y value at what? At -2, since it has shifted downwards. This one, it now have the x values because it was shifted 4 units up. So as you shift this graph up, if you just shift this graph up, you see that it's gonna have the solution, but it's just gonna be wide open like this. Having the solutions, it can actually be like that. So what you need is to compare, is if the graph, is it having a negative on x squared, or is it having a positive? A negative, the shape, it's a sad shape. Positive, it's a smiley shape. Then next is, are we having something being added or subtracted to these functions? For anything being added, it's a shift. Anything being subtracted, it's a shift going down, plus it's a shift going up. Then we have got the condition of the stretch. A whole number, or the bigger the whole number in terms of looking into the number, that this is 4, this is 8, this is -8. That is how closer your graph is to the y-axis. The smaller the number, the fraction and so forth, that is how wide open the graph is. So that's what you just need to know, the whole thing in your syllabus when it is for you to sketch. But in most cases, they sketch this for you because you're gonna need to know a hyperbola, all these graphs. So they will actually do those sketch for you. What you just need is to answer questions pertaining those graphs. So you shall see question papers on functions. How do you answer those typical questions? Like I said, the most important part is just for you to have an understand, the basic understanding. But in the question papers, you're gonna see a little bit way of asking of these questions. This is just like for you to understand like the basics of the graphs. Okay, we shall see more in our revisions.